Hello! Today, Teacher Annie is going to introduce their students to the idea of permutation. Dear students, do you know what is the number of ways we can arrange things when the order of the arrangement is important? And how many possibilities are there? Let's see an example with a sofa. Suppose that exactly three people can sit at the sofa. Seat number 1 on the left of the sofa, seat number 2 in the middle of the sofa, and seat number 3 on the right of the sofa. And let's say we are going to have three people who are going to sit in these three seats, person A, person B, and person C. So, how many different ways can these three people sit in these three seats? First method is we can list all the possible arrangement. We can put person A in seat number 1, person B in seat number 2, and person C in seat number 3. We could think of another situation where person A is still in seat number 1. We could swap B and C. Thus, we have A, C, B. So, that's all arrangement where we have A in seat number 1. Do the same for person B and C. You can pause the video if you want. Finally, we got all possible arrangement of 3 persons in 3 seats. So, there are 6 ways we can arrange them without repetition. It seems pretty easy, right? However, if we deal with larger number of persons to be arranged, such as 100 persons in 100 seats, how can we find the number of permutation? Let's use another approach. We start with seat number 1. How many different people could sit in seat number 1 assuming no one has sat down before? Well, 3 different people could sit in seat number 1 where either person A, B or C. What about the second seat? It is 2 people, either B or C, A or C, and A or B because we already choose 1 people out of 3. Teacher Annie asked students whether they can guess how many different people could sit in the third seat. Ahmad answered 1 people left as we already arranged 2 people out of 3 people. It's correct, Ahmad. Yay! Then what we do to find the number of ways to arrange all these people without repetition, or we can call number of permutations. It is multiplication rule where we just multiply each of the choices for every seat. And we get the answer 6 or 3 factorial. 3 factorials means that we start with number 3, then multiply with number less 1 than 3 until number 1. Thus, we can say that the number of permutations of n objects or any objects is n factorial, or we can write as npn, where we have n number of things in our example before is 3 persons to occupy n number of places or seat based on our previous example. Next, how about we want to arrange these 3 people in a round table? Can you guess what is the number of ways to arrange them? It is the same or different with arranging them in a line. We know that the number of permutation of arranging 3 people in 3 seats is equal to 6. So, this is among 3 ways where we can arrange 3 persons in a circle. In line, if we shift the person by 1 spot, we will get CAB, which would be a new arrangement. But in a circle, if we shift each one by 1, we will get CAB, which not a new arrangement because we just can rotate in the circle to get it. Thus, we can say that ABC, CAB, and BCA, when arranged in a circle, are calculated as only one arrangement. Same goes to other 3 permutation. ACB, CBA, and BAC is counted as only one arrangement. So finally, we can say that the number of permutations of n objects in a circle is given by n factorial, and we have to divide by n so we don't count all the ways that we can rotate it. And it is equal to, after simplification, is n minus 1 factorial.
Hope you enjoy this lesson. Thank you.